Unit 1, Learning Target Number 8. Use substitution to find the solution of an inequality. Before we talk about inequalities, we should probably figure out what they are. An inequality is simply something that says two things are not equal. Inequality, not equal. If you remember, we talked about equations, and equations say that two things are equal. For example, x plus 3 is equal to 4. And we know that x is 1 because 1 plus 3 has to equal 4, because x plus 3 has to equal 4. An inequality says two things are not equal. So you can think of an inequality as something like this. X plus 3 is less than 4. Here are some of our signs that we can use. This means greater than, and this is greater than or equal to. Notice it's got the bottom half of the equal sign there. This is less than, and this is less than or equal to. Notice, again, we have our equal to sign down at the bottom. This is equal, and this is not equal to. Now, some people like to remember the greater than or less than using the alligator idea. So you notice this looks like the head of an alligator. I'm not good at drawing, but maybe you could draw an alligator face there, and there he is. He's an alligator, and he's going to eat stuff there. I'm not good, but there you go, is an alligator. So the alligator is always going to eat whatever is larger. So in this case, 5 is greater than 3. That's a true statement because the greater than is the head of the alligator eating the larger thing. And in this case, we have 2 is less than 5. And again, the alligator is trying to eat the larger thing. So there you go, inequalities. We're going to use substitution to decide if an equation or an inequality can be true. So for example, here's our equation. X plus 9 is equal to 24. Can x be equal to 14? Well, we know that if we want to find the answer to that question, we simply have to substitute 14 back in for x, which means to put it back over here. So we take x and we replace it with 14 plus 9 and ask if that is equal to 24. And is it? Well, of course not, because 14 plus 9 is 23. So we know that this is not possibly 14. So this is false. X cannot be 14. If 9y is greater than 24, can y be 2? In this case, we have an inequality. Again, we're going to substitute the value back in. We'll take the 2 and we'll put it in for the y. 9 times 2 is 18. Is 18 greater than 24? Well, no. So the answer cannot be 2. Could the answer be 3? Well, 9 times 3 is 27, and 27 is greater than 24. So the answer could be 3, but it cannot be 2. And we'll take a look at our last one. If 32 over 8 is less than 4, can A be 8? Well, let's figure it out. 32 divided by 8, is that less than or equal to 4? Well, 32 divided by 8 is equal to 4. Is 4 less than or equal to 4? Yes, it is equal to 4. So yes, A can be 8 because 8 goes into 32 exactly 4 times. Let's use substitution to solve these problems as well. Is x equals 7 a solution to the inequality 2x greater than 14? Once again, we're simply going to substitute 7 in for our x and get our answer. 2 times 7 is 14. Is 14 greater than 14? No, it is not. So this cannot be a solution. Even though it looks like it could be, our sign says greater than, not less than, greater than. So 14 is not greater than 14, therefore the answer is no. X equals 7 is not a solution to this inequality. Alright, how about b equals 2? Once again, we'll substitute 2 in for our b. 27 minus 2 is 25. Is 25 greater than or equal to 23? Yes, it is. It's greater than, so the answer is yes. Finally, which of the following can be a solution for n? Well, let's just plug in different values for n. If we plug the value 3 in for n, we get 3 divided by 3, and that is equal to 1. Is 1 greater than 9? No, of course it's not. So that cannot be the solution. How about 30? If we plug 30 in for n, then we get 30 divided by 3, and that's 10. Is 10 greater than 9? Yes, it is. So that one will work. Let's see about C. What about C? 27. Substitute 27 in for n, and we get 27 divided by 3. 9 is greater than 9. Oh, but 9 is not greater than 9. 9 is equal to 9. So we know that C cannot be a solution. The only solution is 30. Here's a problem that might be a little bit more difficult. Let P be any whole number less than 5. Which inequality is true for all values of P? So for all values of P, which of these is true? Well, first of all, let's consider this part of the problem. P is any whole number less than 5. So what numbers are less than 5? Well, whole numbers start at 0, 1, 2, 3, and 4. Those are the whole numbers that are less than 5. Now let's figure out which one of these is true. A, is P less than or equal to 1 for each one of these? Well, no, it's not, because we have 2, 3, and 4. Those are not less than or equal to 1. How about B? Is P greater than 5? None of these values can be greater than 5, so that's wrong. How about, is P greater than 0? Well, P is greater than or equal to 0, but 0 is included, so we know that that one's wrong. How about this one? P less than or equal to 4. Well, 0 is less than or equal to 4. 1 is less than or equal to 4. 2, 3, and 4 is equal to 4, so we know that D is the correct answer.